The person who invented CNC machine tools is a genius. The ultra-precision CNC lathe, with an accuracy of up to 0.01 micron, can process medical devices smaller than the tip of a needle. This is a precision that human hands can never achieve. So how does this cold metal? How is it carved into impellers, gears, and even curved parts that are too complex to understand? In fact, the reason why CNC machine tools are so precise is not because of the operator's steady hands, but a program code. As long as you enter a piece of code, the machine immediately knows where the knife should go, how fast to go and when to change tools, whether to turn on coolant, and the language that this machine understands is mainly divided into two types. One is G code, and the other is AM code. Don't worry about the names yet. I'll explain it in simple words later. Before talking about the complex 5-axis machine tool, let's start with the simplest one. Suppose you want to carve a logo on a steel plate. You will find that it is actually very simple. The tool only needs to move in two directions, that is, the x-axis and y-axis. This kind of machine tool that only moves in the plane is called a 2-axis CNC machine. It's like a pen, can only draw on paper. At this time, the code mentioned earlier comes in handy. The G code tells the tool where to start and where to go, and what shape to draw, while AM code is responsible for the machine itself, such as whether the spindle rotates, how fast to rotate, and whether to spray cutting fluid. But if I don't just want to draw a pattern, but want to carve shapes with depth changes, at this time the tool must move up and down, which means adding the z-axis. However, you will find that in many machining processes, the tool moves either in the XY plane, or moves up and down along the z-axis. They don't happen simultaneously. This kind of processing method between two-dimensional and three-dimensional processing is usually called 2.5D processing, can make steps and grooves, but it cannot make a truly smooth three-dimensional surface. What is the real three-dimensional machining? This requires the tool move simultaneously in the three directions of X, Y, and Z. The tool moves forward, backward, left, and right, and moves up and down. Then the curved surface will appear. This is what we call true 3-axis 3D machining. But don't be too happy. Some parts still cannot be processed by 3-axis, such as the blades of steam turbines. These parts are not only distorted on the surface, but also when processing, but also needs to be rotated while being processed. So the machine tool began to be upgraded. In addition to the tool moving on the XYZ axis, the workpiece itself also starts to rotate. This adds an extra dimension of motion, which is commonly known as 4-axis machining. At this point, many complex parts can already be made. But it's not enough. Going back to the impeller we saw at the beginning of the video, you will find a fatal problem. Even if the workpiece is rotating, the tool angle is still fixed. Some places the knife can't reach at all, unless the tool can turn. So the 5th axis appears. This axis may be clamped on the tool, or the workpiece. The tool and the workpiece can adjust the angles simultaneously. This is a 5-axis CNC machine. At the 5-axis level, it's hard to control it by handwritten code. In reality, most engineers first create a KS 3-dimensional model, and then hand it over to the CAM software to calculate. The software will automatically generate G and M codes, can even simulate whether the tool will collide, and whether the cutting is smooth. As long as you confirm there are no problems, you can put the program into the machine, and leave the rest to the machine. Of course, machining is not just cutting. Is done. Metal will heat up crazily during high-speed cutting. If not cooled, either the tool will be damaged or the part will deform. So the coolant you see are not for good looks, but directly determine the machining accuracy. These actions are also written in the M code. Finally, when you look back, the picture of a 5-axis machine processing chess pieces, you will find that it is not processing, but more like making a precision sculpture. So now you understand that the essence of CNC is never how powerful the machine is, but the more axes, the higher the degree of freedom, the more complex the shape, what a piece of metal can eventually become. In fact, from the moment you type the first line of code, it has been written.